So now I'm really delighted to hand over to Adam. Adam's been doing fantastic work in building out a new important flower baseline. He's going to tell you all about it and also give you some pointers about how you can look at the resource overheads when you're doing simulations. So with that, we'll hand over to Adam.
Hello. Just a quick recap. Flower baselines are, in simple words, just implementation of very popular papers in federated learning, and we provide easy solutions to reproduce them. And yeah, that's flower baselines in a nutshell. And today I'm going to tell you about feminist baseline, which comes from the Leaf paper. And we used federated averaging strategy, which was also used in the paper. And in order to talk about all of that, I would like to firstly tell you a little bit about the history of the dataset and how it was created, how it compares to very popular MNIST database dataset. And we have a feminist dataset, which was created and initially from the very first huge dataset, which is called NIST Special Database 19. And it still has over 800,000 images of handwritten digits, and also lowercase and uppercase letters. The shape of each of the sample is 128 by 128, and the images are black and white. They're not grayscale images, and as you can see on the left side on the screen, the data was collected using handwriting sample forms, as you see, and there were over 3,500 different writers that the data was collected from, which constituted census office employees and some students from school. And also initially, the recommendation was to use the part of the data set that was created from the students as the test set, and the rest as the train set. And let's move to the next slide so we can see the distribution of the characters presented in the data set. And as you can see on the left side, from the digits still constitute a huge part of the data set. And the next important thing to notice is that, of course, the distribution is not uniform. We have various counts for different letters. And yes, also what I'm displaying right now, what you see right now, is the case when we have 62 classes, meaning 26 letters multiplied by 2 for the upper lowercase plus digits. However, there are also the version that merged some of the letters, because, for example, O, lowercase and uppercase O it's hard to distinguish also when we don't see it in the context of a line, for example. So that's why authors also decided to create a different version of the dataset that has a different number of classes based on where the classes were merged based on the upper and lower class lowercase similarities. Can we go to the next slide, please? Oh no, actually we can move one slide back. So when we have such a data set, Then in MNIST dataset, we have 70,000 samples, which were actually used which were created from the NIST dataset, and it was a mix of the data from students and census employees. And what's important to note is that the size of the images differ, which is 28 by 28, and also by various pre-processing steps, we have the images are on grayscale, meaning they don't have just single binary black-white values, but they have one wider range of values. Coming back to the FEMNIST, and maybe also a word about MNIST, because of the popularity of the MNIST dataset, people decided to that it would be really nice to have really the extended version of MNIST, which constitutes of all the samples presented available in the NIST special database, and that's actually MNIST. It stands for Extended MNIST, and it has all of the samples that were available in the NIST special database. And now the only part that, and finally getting to the FEMNIST, which we are interested in, is we have to have a way to divide the data set such that it resembles federated settings. By that, I mean that each client has only the data set that was produced by a single person, meaning, written. And we see that the division of the data set, which is not that trivial, but we won't go into the details about that, has also varies in size. And we see that the vast majority, or not the vast majority, but a huge peak between 100 and 200 samples, and also some clients between 300 400 that also constitute constitute a huge part of the data set. And yes, when we have such data set, when we know how the data set was created, we can move now to the next slide and talk more about the implementation and the experiments themselves. The model used for the experiment was quite simple convolutional neural network, which has two convolutional layers followed by max pooling and a dense layer at the end. Yes, that network enables us to train such model. And we can see the learning curves, actually not the learning curves, but the accuracy in the next slide, how the training, from the training and test. And here we have the version that was directly proposed in the paper. However, we had some maybe not troubles, but some decisions were not that clear. Therefore, we also propose an alternative set of parameters that we used. We used also this set, but Yes, that we have it visualized on the next slide. Can we move to the next slide? Yes, and the difference between two sets is, or maybe first of all, we just use a subset of the full feminist data set, which is just 5%, as it was done in the leaf paper. And the difference between the first and the second plot, which we can see on the next slide, that the version that we proposed converges way faster. And we also see that we were not able to narrow the gap between the training and the accuracy on the train set and the test set. And the difference in parameters is the proposed version of the federated averaging in the paper was the length of such training for each local client was just for 5 batches, meaning just 5 batches for a single client. And we just flipped it slightly such that the length is 5 epochs, and the division of the train and test set are quite different. It's 60%, 20%, 20% training validation test in the paper originally, and we used just 90%, 10% training test that you can see the results on the platform. I think that's all regarding the feminist baseline. There were also some other experiments and of course also other data sets that we haven't covered, but feel free, maybe we'll cover them in the future, and feel free if you want to also to contribute. And now we can move to the
just before you move on to the next topic, I just wanted to just ask a couple of questions. So just to summarize, now inside Flower Baselines, people can go to that part of the repository and they can find everything they need to perform feminist experiments. That's one big takeaway, right?
Yeah, that was important to state. Yes.
Great. And then you mentioned that they'll find other experiments from the original leaf paper there that the code is there that they can execute if they desire.
Yeah, I mean, there are certain part of the code that enables to do the required training for the remaining experiments for the for the leaf data, for the feminist data set. However, there are some additional computation of flops and something also that I forgot.
Okay, perfect. That's a great contribution. We've heard from many people who need the feminist baseline, and so it's great that we have that now there for people to use. And I do believe also you nearly finished a blog post that we'll post in the next probably week or so that will summarize much of this information too. So that's fantastic. Just wanted to make sure we kind of like had a capstone on that particular topic. Great. Thanks so much, Adam. This is great.
Yes, and now we can move to resources monitoring, and we can move to the next slide. I'll just quickly mention the core ideas behind monitoring simulation in Flower. And for all of the people that don't know what simulation is, it just enables to run experiments in a very easy way that resemble federating settings. And there is a blog post in which you can find all the details that I'll mention. There are two major software packages that we used to enable the simulation monitoring, which is Prometheus and Grafana. Prometheus is used for data collection and Grafana for data visualization. They can be installed quite easily, especially for Mac users using the Homebrew package. The results of starting simulation and how to start it will be on the in a few slides. The results you can get is you can have the visualization of the many resources like CPU, GPU, memory, and it can be seen on the Ray dashboard, which is available only during the runtime, and also on the Grafana, which you can see also after you're done with your experiments. I think we can move to the how to start such simulation. What we need is one argument, one additional argument to the Ray init arguments in the start simulation, which is just include dashboard. We have to mention that explicitly that we need it, and also what you see on the slide is that you can specify the number of CPUs and GPUs in total, as well as for each of the client. What is important is the important thing is that the Ray doesn't itself know how much it's not necessary for Ray to know how much resources you're going to use. It will be the computation and the order of it will be based strictly on the values that you provide. So for example, you can say that you have a single CPU and that you give each client one CPU, and it will and such settings will result in consecutive run of the client, so there will be no parallelism in that case. And based on the results that you can see on the Grafana, for example, you can adjust the values here, especially for the client resources, such that it meets your hardware, that you can efficiently allocate it based on your hardware capabilities. And I think that will be all. Thank you.
Thank you so much, Adam. Those two really important pieces for the community. And so it's great that you shared that with us today. Also, I think you're always doing so much work answering questions on Slack and contributing pieces of code and so on. So I think it's a great opportunity also for people to get to know you. So it's great.
If you have any questions, feel free to ask them on Slack.
Okay, great. So thank you again, Adam.